Okay, we're going to do some more example problems on word to chemical equations. So my suggestion would be to pause the video, do this on a separate piece of paper or on a blank page in your packet, and then come back and see if you've gotten it correct. You can go through and listen to how I've done it, or you can just check the answer. And then, of course, if you have any questions, please feel free to email me, or when we have a Zoom meeting, ask me when we're on the Zoom meeting. Okay, let's go ahead and start. So again, we want to underline the things, the formula. So we have antimony, and means plus, water, reactive form is an arrow, antimony 3 oxide is another formula, and is a plus sign, and then we have hydrogen. Okay, let's go ahead and write this out. Antimony is Sb on the periodic table, plus water, reactive form, antimony 3 oxide, so this is an ionic compound. This Roman numeral tells us that that's what the charge is a plus 3. Oxide is oxygen with a -2 charge. These charges don't cancel, so they're going to swap and drop. So we're going to get a 2 down here and a 3 down here. Now we can cancel them. And then and plus sign. Hydrogen is a H. It's a diatomic, also known as a Brinkelhoff, so we're going to put a 2. Okay, now let's go ahead and let's balance this. We have 1 Sb, 2 Sb, so we're going to go ahead and put a 2 in the front. We've got 2 hydrogens, that's lovely. We have about 1 oxygen, 3 here, so we need to put a 3 in front of the water. Okay, now that we've done that, we've now changed our hydrogen to 6, so over here, 2 times what makes 6? 3. 3 times 2 makes 6. Okay, now let's double check. 2 antimony, 6 hydrogens, and then we've got 3 oxygens. So now that is a balanced chemical equation. Okay, let's do another one. There that one is. Okay, this one we've got magnesium. Metal's just telling us more about it. And is a plus sign. Copper 2 sulfate. Reactive form is our arrow. Copper and magnesium sulfate. Okay, let's go ahead and write out these equations. So magnesium is Mg. Since it's by itself, we have to ask, is it a diatomic? The answer is no, so we're just going to leave it alone. Copper, Roman numeral 2 means it's a plus 2. Sulfate, that 8 tells us it's a polyatomic ion, which is SO4 with a -2 charge. Those charges cancel. Reactive form is our arrow. Then we have copper. Since it's by itself, ask again, is it a diatomic? It is not, so just leave it alone. And is plus sign. Magnesium is Mg. It's in group 2, so it has a plus 2 charge. And then sulfate is SO4, -2 charge. We find that again on our polyatomic ion sheet. And now that cancels out. Okay, let's go ahead and balance this one. 1 magnesium, 1 magnesium. 1 copper, 1 copper. 1 sulfur, 1 sulfur. 4 oxygens, 4 oxygens. This one is already balanced, and sometimes this happens. You can either write the word balanced out to the side, like right here, or you can just leave it alone, because you should know that it's balanced if you don't have any coefficients in front of it. Okay, good job. Let's do another one. Okay, this one, we have got sodium sulfide. Reacts with our plus sign. Hydrogen monochloride to produce arrow, sodium chloride, and dihydrogen monosulfide. Okay, so first of all, I have not taught you how to name covalent compounds because it's not something that they have in the Utah State curriculum for chemistry anymore. So when we go over these ones with the prefixes mono, di, I will just tell you what those are. So don't worry about that. Okay. First of all, sodium sulfide. So sodium is Na. It's in group 1, so it has a +1 charge. Sulfide is S. It's in group 16, so it has a -2 charge. These charges don't cancel, swap and drop. The 2 is going to come behind the sodium. That 1 is already being represented by the sulfur, so we don't need to worry about it. Reacts with Hydrogen monochloride, this is just HCl. Again, on the test, I would give this to you. And then to produce is arrow. Sodium chloride, again, look at your charges. Sodium in group 1 has a +1 charge. Chlorine has a -1 charge. Those are just going to cancel. And as your plus sign, dihydrogen monosulfide is H2S. Again, I would give you that on a test, the ones that have these prefixes of di and mono and so forth. Okay, let's go ahead and balance this. I'm going to go ahead and erase those charges so it looks a little bit nicer. Okay, so now we've got 2 sodiums, 1 sodium, so we're going to go ahead and put a 2 right there. Then we have got 1 sulfur, so that looks great. Now let's go to chlorine. We've got 1 chlorine, and this one we have 2 because that 2 goes to everything behind it. So we have 2 chlorine here. We only have 1 here, so we're going to go ahead and put a 2. Now we're going to go to hydrogen. Remember, we leave that till the last unless we have oxygen. Then oxygen's very last. 2 hydrogen right here, and right here we have 2 hydrogen. So I think now we are balanced, but let's go ahead and double check. Again, 2 sodium, 2 sodium. There. 1 sulfur, 1 sulfur, 2 hydrogens, 2 hydrogens, 2 chlorines, and 2 chlorines. So now we have our balanced chemical equation. And there it is. Look, there it is. Okay. All right, let's do one more. Okay, this one, we've got hydrogen peroxide, and I'm giving you the formula because this is one that isn't very common. Decomposes means arrow, so sometimes we have reactions that break down, and it decomposes to form water and oxygen gas. Oh, and is our plus sign. So let's go ahead and write this one. Hydrogen peroxide is H2O2, decomposes to form water, which is H2O, plus oxygen gas. Now, it's just telling us what state of matter the oxygen is in. You don't need to worry about that in an equation. But we do need to ask ourselves, is this a diatomic? And the answer is yes, so we're going to put a 2. Okay, now let's go ahead and balance this. So we've got 2 hydrogens, 2 hydrogens. That looks lovely. Then we've got 2 oxygens, and here we have 1 plus 2. We have 3 on this side. Okay, so the other day I talked about how when we only have oxygen in one location, like right here on the reactant side, and we have it in 2 or more locations on the product side, or vice versa, this one becomes the control. So 1 doesn't work, so we're going to put a 2. Okay, now one thing to watch out on this one is it's not only affecting the oxygen, it's also affecting the hydrogen. So let's go ahead and balance the hydrogen first. So 2 times 2 is 4. Here we have 2. So in order to balance this, we got to put a 2 in the front. Okay. Now let's check to see what it does with the oxygen. Oxygen is 2 times 2, that's 4. And here we've got 2 times the 1 is 2, plus 2 equals 4. So now this is now balanced. If that 2 did not work in front of the hydrogen peroxide, we'd go up by 3. If that didn't work, we'd go up by 4. If that didn't work, we'd go up by 5. And of course, every time we're going up, we're re-looking at the other side to make sure that we are having a balanced number of atoms on both sides. Okay, so there is that one. Here it is balanced. Okay, I hope this helps. Again, let me know if you have any questions. The Zoom meeting is tomorrow from 10 to 11 a.m. That is Tuesday the 24th, and our next Zoom meeting after that will be Monday from 10 to 11. The link is in your email on Canvas. Have a great day. Bye.